Yeah, so here we will see some picture about the current status of the building site, the Italian demo site. So this is the current status. So as I was telling you, are missing the glass about the windows at the ground floor. The other floors are almost finished inside. We need just to wire the bus cable, all the sensor, and of works need to be done, as you see. So this is the backside of the building. This is the main facade of the building. So here it seems more finished than the other. So here you can see it's all finished, but the ground floor not. For this reason, we are not going forward in order to finish it. The windows should arrive today, I assume. So the company sent us an info that we're arriving today. I hope that it will be true. Okay, ground floor. So here we can see a little bit more zoomed. The electric meter. These are public electric meter, a company that provide electricity. And here we can see the place where we thought to locate the router and the Raspberry Pi. Okay, and so these are all the pipes that we installed in order to make that connection. Also in the ground floor, as you can see, so the frame are no, here it's not the frame also. So here there is a kind of frame are missing. Here we see also the and okay, as you see here is missing just the finishing the floor and the finishing about the electric systems. Okay, here we can see some windows already. The Unit B office at the ground floor, Unit A and Unit B. Okay, that's it. This is what I was telling you. After first floor, the first floor is almost finished. First floor is finished also with the flooring and also with the electrical system. Second floor, but the second floor we don't consider a hole in the Sphere project, as we were cutting some expenses. BIM model. BIM model. This is an overall view. So you can see the direct expansion unit, the external direct expansion for each unit of the apartment, and this is a unique direct expansion, exterior direct expansion unit for the whole ground floor. So unit A and B. This is a little zoom. Here we also the electric meter and the Raspberry Pi or the box. And this is just a view about the ground floor with the internal direct expansion unit. Okay. Sorry, guys, can you hear me?
Yeah, please.
Yes, yes.
Loud and clear. It sometimes breaks up a little bit, but it's okay. Please
okay, no, because Luca was shouting to me that was not okay, the line. Okay. But I think they are quite easy concepts, so it's not, it's not really important. So it's good to show. I think that you can understand everything. It's not a problem. So these is the ground floor with the internal unit, the sensor, and okay. But going forward, we will see all explicitated. This is the first floor, so the little apartment, where there is the living room, bathroom, and little bedroom, and we can say the big bedroom, so 2 beds, 1 bed. Here at the first floor, we have, instead of the radiator, the radiant floor, we have radiant corp, I don't know, they are called in English. Okay, and this is a screenshot from ArchiCAD. And this is the sensor object, okay? And here inside, we put all the information regarding it. So LG Electronics, Modbus, which kind of ID, Sphere Project ID, the description also. So inside here, there are all the information we need, we could need. And that's it. So this is all the information again. Is more in detail how it will look like, the beam object, and so object setting panel. And here is a screenshot about the meeting room, for example, about the unit B. We can see the indoor HVAC unit, dry contact module, dew point sensor, and the radiant floor manifold. So all these are the so some of the component of Sphere project. So in summarizing, is these three device being installed. So we have them at the office. We need just to install them and so to try them. Here we can see another view about all the system, about the ground floor. Here again, this is the living room about the first floor, so it's an apartment. And here, this is the verification. The verification, yes, done with Solibri in order to check if the quantity given to ISDE were viewable. So we make this check. And finally, so we show you the device and the sensor arrived at our headquarters. So they're here: dew point sensor, dry contact Modbus module, and thermal energy meter. So we have also the electric energy meter and the sensor power supply. And that's it. So we need we just Raspberry Pi, but as agreed with COMSA, we will wire everything. We will install also the connection, the internet connection, and they can also check if is so they can see if there will be some bug in order to check all the programming they have done. That's it, guys.
As you have so kindly said previously, I'm Guillermo Reyes from COMSA, and I will be presenting you how we are capturing the data in the Italian pilot, or how we plan on capturing the data on the Italian pilot using a Raspberry Pi based data logger. So in this presentation, I will go over the general scheme and then some hardware and software tools that we're using, then explain in brief detail the software architecture for the data capture, and finally a demonstration on what we currently have in terms of hardware. First of all, it's important to have a bit of a context on how this solution came to be. At the start, as I understand it, DHMWare had a pilot that they offered in the project. And the plan was to add some sensors that would then go to the IoT platform hosted by IDP. This data would then go to iMan and iPredict and other tools that could possibly be developed upon the data. But there was a problem, which was that this step of sending the data was not easily solved. So that's where COMSA comes in. We have developed a data logger that has the capability of interfacing with all of the sensors that DH5 will be installing in their pilot, as you have seen in the previous presentation. And also will be able to send the data over to IDP. Therefore, enabling the whole architecture that the whole flow that you see in your screens right now. In this presentation, we will be talking about mainly the data logger and the connection between the data logger and IDP, which is currently perfectly working from a secure location in our offices at Barcelona. Okay, so first of all, in terms of the general scheme, it would be important to remind what the sensors that are connected will be. We have seen them in the previous presentation, so I will skim over these very fast. It's just that we will have electric sensors, gateways with the HVAC units, outdoor temperature sensors, some thermal energy for the gas boilers, and some sensors in the rooms measuring relative humidity and temperature independently of the HVAC units as well. And that all of these is connected to a Raspberry Pi with some HUDs that expand its capabilities, which is then connected to a router that will be able to send the data. This is more of the hardware kind of scheme that we're using. In terms of software, we have this Raspberry Pi based data logger that over Modbus will pull data from all of the sensors, and then using an instance of Node-RED, will transfer over MQTT protocol all of the data over to the IDP cloud server, which is currently running on Microsoft's Azure platform. So first of all, let's go over what the hardware that we're using consists of. First of all, we have a Raspberry Pi, which is a processor unit capable of running a whole operating system on its own. Currently, it's running Raspbian, which is a distribution of Debian, one of the most famous Linux distributions that currently exist. And it's actually quite potent for its size. You will see it integrated in the whole data logger later on. And most important of all, it can be expanded, and it has Ethernet capabilities, which eases the connection quite a bit. In order to be able to actually pull on Modbus data, we have this expansion card or HAT that goes just over the Raspberry Pi. This HAT has basically two RS485 channels that allow us to interface with all the sensors over Modbus RTU protocol. And it's just conveniently prepared just to be a plug-and-play solution over the Raspberry Pi that has pretty much worked from the start. So when we integrate these software, these hardware tools, we get this data logger, which you can see on screen. This is when it's closed and perfectly protected. It has a pilot to indicate that it is working, and a button that allows us to manually reset it, which is a very important feature if something goes right. This is how the data logger looks when it is opened. As you can see, you have the Raspberry Pi and the expansion card on the left, and we have a series of energy converters that allow us to power as both sensors and the Raspberry Pi itself, and some terminals that where the sensors will be connected over Modbus RTU. This is a scheme of the data logger, just for convenience and clarity. And it has been designed from the ground up and put together mainly thanks to Antoni. He's one of the main sponsors of this data logger. So in terms of the software that we're using in order to accomplish all of this, first of all, we have Node-RED. Node-RED is a graphical programming platform that can be installed in practically any device, and that runs and that can be accessed over the browser. So it is actually very convenient in that regard. And it's mainly a platform that aims to allow you to integrate basically any hardware that you have installed with online services. What we're doing here, it's one of the architectures that is pretty much the reason why Node-RED exists. Mainly, it also has Azure integration as a baseline, so that also is a very interesting feature for the kind of data transfer that we are trying to accomplish here. And speaking of Azure, that's another part that's very important in the mix. Azure is more of an IDP prerogative more than ComSAS, but still it's important to understand that it's mainly just a hub where you can manage data from many incoming devices, and that it basically ensures some standards of security that are actually quite important. Last but not least, it is very important for us the use of MBPOL. It's a free and open source software that basically allows easy interfacing with all of the Modbus devices that we have installed. In terms of how the software architecture is constructed, what we have installed in the Node-RED that you will see shortly, it's basically two parts. One of them is obtaining the token from the Azure server in order to credit that we are indeed the data logger and that everything is securely connected. And then a second simultaneous part of the program queries all of the Modbus devices and formats the data into a JSON object. It's just a type of data structure, which is then sent over to IDP. And without further ado, let's see a little demonstration.
We're not hearing the sound of the demo. It's a typical challenge.
Oh yeah. Okay. Sorry about that. Let me try and stop the. Sorry. Let me stop the presentation for a minute then and put and share the video with you in a more direct approach that I'm sure will.
One possibility is that if you put the speakers on for a while and then we hear it from the mic, so that might be simplest at this point.
Yeah. Just let me Just let me try this for a minute, and I will. And if this doesn't work, I will just do as you say. You can see it now.
Yeah.
Okay, let's see if you can hear it.
No, Teams doesn't have good integration.
So you're not hearing it.
No.
No, I think we had the same problem with VTT earlier. One other thing, but best way is put the speakers on, and then you hear it through the mic. So it's simple.
Okay, let me try. Okay.
No sound yet.
Okay, just that I don't really have speakers, so I was trying to connect the. If you're willing to allow some slack, I will just try and just I should be able to actually see some.
If you want, I can try from my side, Guillaume.
Do you have the video?
I have the video. It was sent by Enrique yesterday. I can try.
Yeah.
Okay. I actually, if you don't mind, I can. I mean, this is intended to be a live demonstration, right? So
there is a setting. There's the last thing you could try. There's a setting if you share the content. There's a button that says include computer sound.
Oh, maybe that's a thing, but as I was saying, just let me just present to you the I mean, we had a video prepared just for clarity's sake, but we can go for a live demonstration, which I think you can also appreciate. I mean, I also know the content of the video. You can see this my screen right now, right?
Yeah. Do you want me to try the video on my end?
No, don't worry.
Okay.
We can go for the live demonstration. The first of all, I just wanted to show you the whole program. This is the program that actually queries all of the Modbus devices and sends the data over. There are currently 84 variables, so it's pretty hard to make sense of it right now. So that's why we prepared a simplified version so that we can look into it in a more secure environment. So this demonstration basically goes over 3 of the devices. 2 of them are connected currently in our office in Barcelona, and one of them is not connected. This device is currently not in the office, and it's not connected to the device, so that's why it gives an error, and that's unexpected behavior. So as I said in the presentation, basically we have 2 parts. This part over here, all of these nodes basically just ask for information from the ask for security tokens from the Azure server, and gets them and prepares them for the for being sent. And all of these nodes here query the devices. They query all of the devices sequentially and with 100 millisecond minimum delay from device to device, just to ensure that no overlapping or errors in that regard happen. These devices are queried as fast as possible, and every time a valid value is recorded, it is stored over 5 minutes until a more recent value is recorded. And when all those values are recorded and we have the security tokens, which are received every 5 minutes, then the data is sent, and all of the stored values are erased. That way, we make sure that all the values that we get are from that 5-minute time frame. in this demonstration, just so that we can see some movement, we have set it for 30 seconds instead of 5 minutes, but in the final product, it will be 5 minutes, not 30 seconds. Anyways, let's look a bit into what the data logger is currently sending. For example, one of the measurements from one of the sensors that's currently connected, the inner temperature. As you can see, it moves quite a bit just because it's currently working at 30 seconds. It's not this vector, it's this vector. So as I was saying, this value is actually recorded. It's a true value. It's 26.2 degrees currently at our office. And if we look over at the device that is not connected, what it's sending, it's saying that it's not a valid value. So it's the fact that it's a valid value, it's false. And it says that the value is not a number. That's two easy ways to detect any mistakes or errors that we have. So that's pretty much what the program does. What you see in the big program that we saw earlier, that's currently disabled, just to make sure that the demonstrator is working. It's just that structure, but repeated over and over for all of the devices. And whenever the pilot is ready to receive our data logger, we will be sure to send it over and keep on progressing in this regard. So sorry for the technical problems. That was basically everything we had prepared for today.
Beforehand, we talked, and I was asked to not show slides, just demonstrate our Flink2Go tool. So that's what I will do now. Flink2Go is it's a tool for easy detecting and managing defects on the construction site. I guess you probably all know it more or less, and I also guess that Pietro and Di5 are more or less, or become more or less experts in using Flink2Go, because they did a lot of testing with it, as I've seen. But nevertheless, at first I would like to give you a short overview, and I will end this small demonstration with our latest features and a small look into the future. I hope you can see my screen. If something is unclear, please just let me know. I can't see a raised hand, so just scream and say hello or stop or whatever, and then I can answer a question or whatever. Yes, at first I can log in, and then I have an overview. So yeah, it's my name at the moment is Sphere Admin. So normally there you can see your own name from the user that you've logged in with. Here I have the overview about my current projects. Here, this, for example, is the Di5 pilot site from Pietro and Di5, but we will now have a look in the Sphere project pilot. Yes, and when we enter this project, then the first thing that we can see is the overview about our current tickets, about all the open tickets and the tickets that are in work, so that we have directly a good overview about everything. When, for example, I can click on one ticket, then I got the overview or the details about the details of this ticket. I have a title. I can see where this defect is located. So the defect says, okay, there's a leaking roof window and it's in the main building on the first floor. Obviously, it's the Craft roofing work that is responsible for this defect, or that should take care of this defect. There can be added some comments. So I can say, for example, roof window is still leaking. If I want to, here I can say who is internally and externally responsible for this work. This is connected to the roofing, to the craft, or to the person who's responsible for this type of craft. So I can't just choose anyone. I have to choose the right person. It's always pre-selected so that you just can select the person who's really responsible for this. Now I can save my my new comment here, so it's now added to this ticket. Yeah, we have different sections for this ticket. Here's, for example, our history. There you can always see the history, who has added what at this ticket, or who has changed something. We have a section for photos, and we also have a section for documents. For example, PNGs or PDFs or whatever, so that you can add documents who are related to this ticket. For example, on the photos, this is something that is relatively new, or that we have developed within Sphere. It was something that raised distingue, because, and I think Pietro, you again said it a few minutes ago, that sometimes for your case, Flink2Go is a little bit too slow. I guess this was what you said, because maybe sometimes it's a little bit too much to fill out and too complex to what you have to add into this ticket. So you said it would be great if you had the chance to just draw on the pictures, and that's why we added this new section. Here you can, for example, create an arrow to something, or you also can draw with your finger. This is especially, or with the mouse on PC, it's not that great. But if you use it on your phone, then it's easier, because you can just draw with your finger, and then, yeah, I guess it's more useful. You also can make a circle around something that you want to highlight. Yeah, and then you can save those changes, and the person who maybe is responsible for fixing this defect directly has a picture of the defect, and with a circle or an arrow or some notes written on it, so that there are more, or that there's easy notes on it, and that you know exactly what you should focus on. Yes. So maybe we want to create a new ticket. For example, we can say, oh, I have to save it. For example, we want to say, okay, there is a leaking pipe in the bathroom. I don't know. So then maybe we should at first have a look, is there already a responsible person for this craft who's responsible for bathroom defects? So I guess it's gas washer and drainage installation. So, and then we can see, oh, there's no craft or responsible person added to the system at the moment. So I think alarm system is not the right thing. Roofing work as well, concrete work is also not the right craft for it. So then if this is the case, we can go to settings, discard, and we should add a new responsible person for this typical craft. So we choose the craft responsible, we add the craft gas, water, and drainage installation. Then we need an external responsible person. So maybe we choose Nicola. Internal responsible person is, for example, Pietro, and we save this. Now we have a new, can see it here. Now we have this new responsible person for the craft, gas, water, and drainage installation. And we can go back to our ticket overview, create this ticket. We have a leaking pipe in bathroom, for example. We choose main location, main building as a location. It's in the first floor, for example. And then we need to choose the right craft. And yeah, it's always a problem when you show something live, then, as you can see, it's not there. I don't know why. Maybe we choose general at the moment, but actually it should be there. And when I've tested it, it was always there. But yeah, as you can see, we are still missing the right craft here. Maybe go back to the settings and have a look. What could be the problem? Here is gas water drainage installation. I will try it with another craft. Maybe we choose this one at the moment. And yes, go back to tickets. Maybe I just do a reload. Hopefully this could help. Create the ticket again. And here you can see now all of this, what I've added is there. It was just a problem of reloading. Yes, exactly. We will choose this one. Typing again, title, it's the leaking pipe. We have a leaking pipe in the bathroom. The wrong field should be in comment. And then we have here automatically Pietro as internal responsible person and Nicola as external. And because we have chosen the first floor on the main building, we directly have the plan of this floor here added because it's added to the general information of this building. So we have it directly here. We can save this ticket and now we say, okay, maybe it's useful to add also a picture of this leaking pipe. Let's have a look which one would fit. Maybe this one. And we can add this picture. As you can see, they are still on construction. Yeah, it's a little bit too small, this picture, but we also can mark here, for example, this area is the area where the responsible person should have a look at. And we can save it. Yes, right. For example, another thing, you can have a look on this ticket here. There you can see the internal responsible person that is as me. It's my other account. So I can show you something with this. When now I can change my role, for example, I will log out. Now at the moment I'm still the admin, and now I will log out and go to my other account. Then I'm a responsible person, and this is a difference. Now you can see I just have access to the Sphere project and not anymore to the Jingra project because I'm not a responsible person for this project. So I just can see what I'm allowed to see. And when I then click on this project, I have access to the ticket I've shown you on in the other account with the general defect, the responsible person, it's me, and I can add a new comment, for example. I can save it. I can also do some drawing here on this. Maybe I do this and that and save it. And I save all my changes, so a new comment and some nice drawing on this floor plan. And when I then log out again and go back to the admin account, then hopefully we can see all the changes I've made. So go back to the general defect. This is my ticket here. And we can see, okay, here's the new comment that I've made. And we can see here, not the drawing again. So in the overview, maybe also again a problem of right loading. So you can see it here in the thumbnail. The drawing is there. To be honest, I have no clue why it's not here when I open it. I will write it down and tell it to our developers that they have a look at it. But normally it should be there. Yes. So this is the current status of Flink2Go, but that's not all. So the one thing that was raised was, as I told you, that it would be nice when we can draw some things on the pictures. And the other thing, or the other requirement was that it would be great to have a better insight into the building and where the defect is located within the building. So that's why we said it would be really nice to have a 3D visualization of this building within Flink2Go. And we already did really successfully a proof of concept. We used COGL for this to visualize the mesh of the 3D mesh of the building. At the moment, we are working on integrating this proof of concept into the backend and into the front end of Flink2Go. So in the future, it will be located here below the other general informations of the ticket, so that you then can click on the 3D model, a pop-up window, or a window will pop up where you can see the, for example, the floor or the roof where the defect is located, and that you can move within this floor on your phone or on your PC. So, and the location will be, or the view that you will have on this 3D model will be chosen by selecting those location settings here, so that you don't see that you don't have to see the complete building and then move around within this building and try to find where your current location is, so that you just zoom directly into the right location. To get a better overview about the complete building, we also will integrate the 3D visualization here and the building overview. At the moment, you just have here, or you can add your different buildings from the construction site, and for every building you can add the different floor plans or water pipe plans or electricity plans or whatever you have. But we also want to add here the complete 3D model of the building. Yes, current status is that we are working on the integration, and we are also working on the data exchange with the NearNext. So hopefully in a few months, there's something more to show, and that we can show you then the first 3D models within our Flink2Go tool. Yes, that's from my side. So
I will make a quick introduction and overview just to contextualize how the energy management system tool have been developed, because it's, let's say, a slightly different story from other tool, as you know, because probably you have followed presentation during other work packages. So the energy management system is part of task was developed as part of task 5.3 as energy management workflows according to the core principle of the ISO 50001 standard. And the task asks also to identify energy sources, significant energy uses, and possible improvement opportunities for pilots. And in June, as you know, the deliverable 5.4 was submitting, where the development of workflow has been done. And the workflow are made, as I will show later, of tasks that are, let's say, chunks of action of the entire flows of action required in the ISO standard that focus on, let's say, setting objective and find a way to continual improve the energy management of an organization, aligned also with other management standard as 9001 related to quality or other environmental standards. In June of this year, a report was completed where outcome of tests of all the pilots of the, let's say, the paper version of the energy management system has been completed. VRM began to develop a digital version of the NMS in integrating it in their platform. But then, so it just started from a light testing version, but after they left the project, as you know, it was discussed how to involve other partners to work on this aspect. So Ascora started a collaboration with R2M in June, and they were the collaboration has shown very positive. So we are very happy of the development of the digital version of the tool that, let's say, it's appear like a light testing of the tool developed in the, let's say, in the paper version. So the purpose in general is to offer a framework based on the ISO 50001, and that can offer the experience to provide the possibility to a structured walkthrough for building stakeholders that can go from owners to operation and management staff and facility manager, and allows also to collect required data and documented information as for the ISO procedure. So these are an image that summarizes the workflow that have been developed following the core section and principle of the ISO, and following, of course, the naming cycle of Plan, Do, Check, Act that I think most of you are familiar with. The workflow are divided in stage. Each stage is made of a task, and the workflow have been developed in the deliverable also in a way that could in a further occasion be implemented in the digital tool. So already in a perspective of the documented information and the status and approvals. These are example of workflow, for example, related to leadership aspect, energy policies. We also try to define some logic patterns about this, and describing the task we have that compose a workflow. We have two kinds of tasks. The first kind is descriptive and compilative, that require narratives or defining procedures or policies or defining non-conformities. And then we have data-related tasks. For example, we table, dashboard, energy data, KPIs or energy performance indicator. And so you can say you can see some example of what have been developed. So the tasks are made of a very brief narrative and some tables, samples, checklist, and this is already have been developed in an idea to implement it in a digital platform. The finished pilot Caverion included the genuine input in the deliverable, providing so a first test of the provided tables, compiling it with the energy data, since it was the only existing billing at the time, and also with improvement opportunities information. And then in June, we asked all the other pilots to test the paper version, so the tool implemented. Going from paper to digital, so the goal, as I said before, is to implement a light version, so not a fully viable tool, let's say, in a digital platform. And so thank again to Ascora for the great work, where we can integrate the structure of the stage and workflow defined and some selected tasks, and printing, exporting PDF reports, and store a repository of the producer report. And then we are evaluating with Ascora how far can we go in progress of the further development, like customization of tables and samplers, or exporting data, or interaction with other tools. So I will leave the word to Caroline that can better show the progress and the digital platform. But before, I will just mention that with the Italian pilot, we are discussing how to test this light version of the digital platform. For example, upgrading and updating the inputs of already provided, or implementing new tasks, or testing the management of document information, and also, as the Cinque is already doing with other tools, collecting feedbacks, lesson learned, and possible improvement of the tool. So I will leave the word to Caroline that can show in concrete how the platform is working.
Thank you. I will share my screen again. Give me a second. So I hope you can see the tool. So I have to say at the moment it's not the most beautiful tool in the world. So it's still a prototype and it's still work in progress. But I would like to show you what we have already did and how the first steps are. Again, I have no presentation, just or no slides, just the demonstration of the tool. Okay, here on the left side in the menu, you can see the different stages that from the energy management system, like Stefano explained. And for every stage, you have those single tasks there. So you can open all of them, or you can just leave it. However, at the moment, so for every stage, at first you have a short explanation what this stage is about. It's still more or less a placeholder because we took just the description from the deliverables. So this can be adapted if necessary. Yes, and then you can go to the single tasks of every stage, and you can have a short description. For example, now we are in stage 2 on task 4. This is called management commitment. Then you have the description, what needs to be done with this and what is it for. And then you have all the different tables where you have, for this, in this, for example, you have to choose yes or no. It's some kind of multiple choice table. I have to clarify, this is not working at the moment, so it's still just a placeholder. So not really a placeholder. The table already exists in the back end. This is all fine, but we have at the moment no functionality for this multiple choice integrated yet. But as Stefano said, we had no much time to work on it yet, and then we also had some trouble because our main developer quit his job at Ascora. So at the moment I have to find a new one. That's why we have a small pause, but yes, we will of course further develop it, and we'll have progress soon. However, this is, for example, some kind of multiple choice table. Of course, we have also other tables, for example, those free text tables. We will also add the functionality that you can add as a user own rows and columns so that you can customize those tables. This is partly functioning, or it's already partly functioning. But it's not completely deployed yet because it's not completely functioning. So it is still work in progress. But this will be soon integrated. Then we also already integrated a small user management so that you can register and create your own user account. And within this user account, the tool remembers your customized tables so that you just have to customize those tables once. And then you can, when you log in again and reload your tool, that you then still have those customized tables. So it's not useless work. You can save it forever, so to say. Yes. You also can have here some kind of free text table of free text fields. So whatever is needed, we can integrate several tables of checkboxes of text fields or whatever. Yes, what is also possible? So one requirement was, we agreed together with R2M that we will develop this tool step by step. So at first we said, okay, we will at first try to develop those basic features and then integrate more and more things when those basic features are working. And one thing that was really important was that we can export or print those reports. So you have the possibility to print the current page, sorry, and you can print it with your normal printer, or you also can choose as PDF or whatever is needed. They can see here's the text I've added. This is something you can do. You also can archive those reports within this tool, or this is something that will be implemented. It's not completely functioning yet, so that you have here your own survey archive. And it's also possible to export single tables as CSV files. Where is it open? Here it is. I'm not sure. I think you can't see it because I just shared my one window. However, then there's a CSV file opening, but it's completely empty because this table is empty, so it's not really interesting. But however, you can export those single tables as CSV files so that you can use those data also in other tools, for example, or that you can convert to an Excel file. And another interesting thing is that this also opens the possibility to import CSV files, which have the same format, that you can import data from other, that you have filled somewhere else, to use this into the ENMS tool. But this is also still not integrated yet. But this is a possibility which we have with those CSV files. Yes, here we will have in the future the survey archive. As you can see, it's empty at the moment. But there you will have an overview about all your reports that you've created for every single stage, for every single task, and with the time when you've created it, so that you can also compare different reports, so that you can have a look, hey, what did I do with the ENMS strategic issues in 2019? And that you can compare to what is the current status, so what will I do in 2021 or whatever. So this is also something that we will implement. Yes, yeah, it's not, we are not pretty far with the development, as you can see. So it's still in the first single steps. We have all the frame, the backend, and the database are created. Backend and frontend are connected. So those backend things are already working, but yeah, it's not. We have not so many functions at the moment.
So good morning, everybody. My name is Miguel López Guillem. I'm a modeling and simulation engineer at Empresarios Agrupados, and today I will be presenting you the WebDeck service created for the DE5 pilot building. So during the presentation, I will first talk about the model design, how we build the models of the buildings in EcoSim Pro. Then I will talk about the WebDeck service generation or creation and the integration into the IDP portal. And then I will finish the presentation talking about the usability and main functionalities of our software, of the web service. So to build a building model using EcoSim Pro, well, first of all, we take our software, and using the HVAC toolkit, we are able to model both the passive building using the buildings library and all the HVAC systems in the building using the HVAC machinery library. So how do we do that? Okay, so first of all, we need to collect all the relevant data about the building, such as the exact location, weather parameters, the HVAC configuration, IFC files, technical data, PDF files, okay? And with that information, the simulation engineer is able to build the model using EcoSim Pro. And once we have the model, we can generate as a final result the WebDeck simulation. So what is exactly a WebDeck? So a WebDeck is a black box, okay? And inside the black box, we have the mathematical model of our building. So this box, we take some inputs and we generate as a result the simulation outputs. In the case of the DE5 building, we are using as input variables the inner and outer temperatures, the set points of the machinery, and the working modes of the machinery as well. And we can introduce those input variables either manually, or we can use those variables can be taken from an IoT database. So once the webdeck has these inputs, it will generate a simulation output that in this case can be temperatures, relative humidity, or electric and thermal energy consumption. This is from a top level point of view. And if we look at the low level, we have something very similar. We are taking some inputs, either manually or from an IoT database, and those inputs are going to be introduced into a JSON file. Okay, then the webdeck will receive that JSON input file, and we generate as well a JSON output file. We have published this webdeck service into this URL that is the one that IDP is using to integrate the web service into their platform. So the platform is making a request to our web service with the input data, and the web service is returning a response with all the output data we saw before. So this is a screenshot of the IDP platform with the web service integrated, and here you can see some of the simulation results. In this case, we have, for example, the electric energy, thermal energy, temperature, relative humidity, and here you can see as well a graph, okay, a long time. This is for the 26th of October. Here with the evolution of the relative humidity in the different rooms of the first floor. And to finish this presentation, I would like to talk about the usability and main functionalities of the web service. And first of all, I would like to talk about the predictions. Okay, so with the web service, we can make forecasts, okay, about how our building will behave in the future. So for example, let's say I want to analyze the CO2 concentration of a room and how it will raise if the occupation is higher than expected. So that way the administrator of the building, for example, can decide what machines to use. It can define the set points and so on, always to optimize or to maintain the thermal comfort and air quality of the overall building. Then another important functionality is making comparisons between ideal or theoretical results versus the real ones or the measured ones. Okay, and that way we can analyze deviations and see the possible causes of them, and also link to this one the possibility of using the simulation or the model as a redundant option, okay, in case one of the sensors in our building fails. So we can fill that gap of information with our simulation results. And that's all for the presentation. Thank you very much for your attention.